Good morning everyone. This is Preeti here. Welcome back to the series of lectures on soft computing. In today's video, I am going to explain to you about the problems in fuzzy relation. So we know what is fuzzy relation is. So fuzzy relation, it will give you a relationship between the two objects. So it is similar to a classical relation or crisp relation. So in last lecture, we have seen what is fuzzy relation and all the properties. Now we are going to see the problems in fuzzy relation. Let's get started into this video. Consider the two fuzzy sets, A fuzzy set and B fuzzy set. Fuzzy set is represented by tilde symbol. So A contains the values 0.4, 0.3 and 0.2, and x1 having a membership value for 0.4, x2 0.3 and x3 it is having a membership value for 0.2. Let's coming to the next fuzzy set B. So it is for on point y1 it is having a membership value called 0.3 and y2 it is having a membership value called 0.5. So now these two fuzzy set is given for you. Now the problem over here is you have to find out the Cartesian product between the two fuzzy sets A and B. So what is Cartesian product? Cartesian product is nothing but set of ordered pairs such that the first element in the pair belongs to A, the second element in the pair belongs to B. So this is called the Cartesian product. So it is when we are representing this Cartesian product, so we will write this membership of this is the resultant matrix. So I am giving R over here. So first we will take the ordered pair between x1 and y1. So membership value of R of x1 comma y1 will be, so it is nothing but when we take the Cartesian product between this first one and second one, the formula over here will be minimum of membership value of x1 comma membership value of y1. So what is membership value of, this is over here membership value of A of x1, membership value of y1 which belongs to B. So when we find out the minimum of 0.4 and 0.3, minimum value will be minimum of 0.4 and 0.3 is 0.3. So this is the membership value for x1 and y1. So now we will find out the membership value between x1 and y2. So what is x1 and y2? It is nothing but minimum of membership value of x1 in A fuzzy set comma membership value of y2 in B fuzzy set. Okay, that is what I have written here. So when we find out the minimum value, minimum of 0.4 and 0.5, the answer is 0.4. So we have found out this x1 with y1, x1 with y2. Now we proceed on to the next value, that is called x2. So x2 is compared with y1 and x2 is compared with y2. So that is what I have written here, x2 comma y1 and x2 comma y2. So what is x2 comma y1? It is nothing but minimum of between the two membership value. What is 0.3 and 0.3 membership value? Minimum value is 0.3 again. So I am writing here 0.3. Next, finding out the minimum between x2 and y2, minimum value is 0.3. So I am writing here again 0.3. Next, I am going to the next variable called x3. x3 is compared with y1 and x3 is compared with y2. So when I compare x3 with this y1, the minimum value will be 0.2, and when I compare these two, the minimum value is 0.2 again. So the answer will be 0.2 and 0.2. So these are the resultant Cartesian product values. So I can represent these Cartesian product values in a matrix format. So I can write here x1, x2, x3. Since you have having the variables x1, x2, x3 in A fuzzy set, B fuzzy set you having y1 and y2. So I can take this x1, x2, x3 in row as row value and y1 and y2 as column value. So x1 and y1, the answer for this x1 and y1 is 0.3. So I am writing here 0.3. x1 and y2 is 0.4. So I am writing 0.4. x2 and y1, it is x2 and y1 it is 0.3. 0.3, next is 0.2, 0.2. So I can represent all these values in a matrix form. So this is the final Cartesian product between the two fuzzy set. So if any two fuzzy set is given for you, so what you can do is you can use this formula by using this minimum of between the two fuzzy set, two variables, and you can able to derive the Cartesian product between the two fuzzy set. Okay. Coming to the second problem in fuzzy relation. So here two fuzzy relation is given. So in the previous problem they have given two fuzzy set, but here they have given two fuzzy relation. This fuzzy relation is formed from fuzzy set, Cartesian product of fuzzy set. They have given two fuzzy relation and they are asking you to find out the composition between the two fuzzy relation. So there are two composition is available. One is max min composition, other one is max product composition. So we are going to find out the max min composition and max product composition. So always when you are finding out the composition, you should see that. So here how many rows and columns are there? There are 3 rows and 2 columns. So it is 3 by 2 matrix. So when we consider this relation, so we have 2 rows and 3 columns, 2 by 3. So always the column matrix and the row matrix, the column matrix of first matrix and the row value of second matrix should be the same. So when you are taking this composition, so you should see that that is like the column value of the first matrix and the row value of the second matrix should be the same. So when both the values are same only, you can able to do the composition. Okay, so now we will find out this max min composition. So we will that is like we will keep the resultant matrix to be T, and x1, x2, x3 is the values which we are taking for the row values, and y1 and y2, here y1 and y2 are common. So when we have to find out the resultant final matrix, right, so we will have x1, x2, x3 as row values and z1, z2, z3 as column values. So you will get how many matrix? It will be 3 by 3 matrix. You will get 3 by 3 matrix. So this is what you have to achieve. So when you are finding out max min or max product, you should get the result like this, 3 by 3 matrix. So the row values will be x1, x2, x3 and your column values will be z1, z2, z3. So first we need to find out the max min composition, that is T will be equal to R dot S. So R relation is given here 0.6, 0.5, 0.1, 1, 0 and 0.7. Composition with S 0.7, 0.3, 0.4, 0.9, 0.1, 0.6. So we need to find out the max min composition. The formula for max min composition is max of minimum of this membership values. Okay, so we will use this max min composition to find out this value T. Okay, so we know that T, you will get 3 row values and 3 column values. First coming to this 0.6, 0.5, this is similar to how we do the multiplication. So we will take the first row and first column of the second matrix and we will multiply. Usually in multiplication we will do that, but here what we will do is we will find out the minimum of membership value of this 0.6 and 0.7, and we will find out the membership value of minimum of membership value of 0.5 and 0.9. So the minimum value, among the minimum values, we will find out the maximum value. This is what we are going to do it in max min. Okay, so we will use this formula and we will solve this. First, max of minimum of membership value of, what is this value? This is nothing but this is x1, x2, x3 and this is y1, y2. So it is membership value of x1, y1, what is this? This is y1, y2 and this is z1, z2, z3. So when we have to take this, it is membership value of S of y1, z1. Okay, so we need to find out the minimum of this, minimum of this value. What is this? Membership value of x1, y2, x1, y2, membership value of, what is this? It is y2, z1. Okay, so among the minimum values you find out the maximum. So this is what I have written here, max of min of 0.6, 0.7, minimum of 0.5 and 0.9. So what is the minimum value between 0.6 and 0.7? It is 0.6. When we compare between these two, the minimum value is 0.5. So maximum among 0.6 and 0.5 is 0.6. So this is what we are getting it for x1, z1. So here we need to substitute this 0.6 here in this position. Next we need to find out this x1, z2. So what is x1, z2? So if you want to find out this value, it is formed by taking a composition between this first row and second column. So what will you get here? So it is nothing but max of min of this 0.6, 0.6 and 0.3, okay, and minimum of this 0.5 and 0.1. Okay, so the minimum value is 0.3 here and minimum value is 0.1 here. When you take the maximum value, you will get 0.3. So this is nothing but x1, z2. Okay, next we will find out this x1 comma z3. So how will you find out this? This is nothing but a composition between this first row and third column. So it is the max of minimum of 0.6 comma 0.4, then minimum of 0.5 and 0.6. So it is what I have written here, 0.6 comma 0.4 and 0.5 comma 0.6. So when you take a minimum value, you will get 0.4 here. Here you will take 0.5. So when you take a maximum value, you will get 0.5. So this is what you will substitute in this position. Now we move on to this position, that is x2 comma z1. So how will you find out this x2 comma z1? It is nothing but taking a composition between second row and first column. So it is nothing but max of minimum of 0.1 comma 0.7 comma minimum of 1 comma 0.9. So 0.1 comma 0.7 comma minimum of 1 comma 0.9. So minimum value is 0.1 here and this is 0.9 here. When you take a maximum value, you get 0.9. So this is x2 comma z1 is 0.9 now. So when you want to find out this x2 and z2, it is nothing but taking a composition between this second row and second column. It is max of minimum of 0.1 comma 0.3, then minimum of 1 comma 0.1. Okay, 1.1 comma 0.3, 1 comma 0.1. So the minimum value is 0.1 and 0.1. So maximum is 0.1. Okay, so next is we will find out this x2 and z3. It is nothing but second row and third column. So max of minimum of 0.1 comma 0.4 and minimum of 1 comma 0.6. Okay, 0.1, 0.4, 1 comma 0.6. So you are getting 0.6. Next, for finding out this value, it is x3 comma z1. It is third row and first column. 0 comma 0.7, minimum of 0 comma 0.7 and minimum of 0.7 comma 0.9. So you are getting here as minimum of this value 0 and minimum of these two values is 0.7. So when you take a maximum value, you are getting 0.7. Okay, this is x3 comma z1. Now coming to this, it will be third row and second column. So minimum of 0 comma 0.3 and minimum of 0.7 comma 0.1. Okay, so when you take this 0 comma 0.3, 0.7 comma 0.1, so you are getting 0.1 here. Next, coming to x3 z3, the last value, this is third row and third column, 0 comma 0.4 and 0.7 comma 0.9. 0 comma 0.4, 0.7 comma 0.9. So you are getting 0.6. So when we substitute this, you are getting this resultant. So when we want to find out the max min composition, first you have to check that the row vector, that is a column vector of first matrix and the row vector of second matrix should be one and the same. Then you have to form the resultant matrix by combining all your taking a composition between this rows and column values. So you have to use this max min composition, means maximum outside and minimum inside. Okay, by using this you need to find out and you have to substitute this values, you will get your resultant matrix. So this is how you have to do max min composition. Coming to max product composition, this is similar to max min composition, but only change is that you should do the product. That is, here in max min you will be taking maximum outside, inside you will be finding out minimum. Instead of minimum, you need to do a product, that is multiplication of membership values. So we will try to find out the composition between these two. So we will check whether the column vector of first matrix and row vector are same. They are same, so we can easily find out the composition. So T will be x1, x2, x3 and z1, z2, z3. First we will find out this value x1 comma z1. So what is x1 comma z1? It is nothing but composition between the first row and the first column. It is 0.6 max of membership value of x1 comma y1, membership value of y1 comma z1. Okay, so this is dot product comma membership value of x1 comma y2 dot membership value of this y2 comma z1. Okay, y2 comma z1. So in short, okay, if you are not able to write out this formula, you can go to this. So it is nothing but max of 0.6 dot 0.7 comma 0.5 dot 0.9. So what will you get? 0.6 comma dot 0.7 is 0.42. When you multiply 0.5 and 0.9, you are getting 0.45 here. So you take the maximum value between these two. So you are getting 0.45. Okay, this is what you will get. So when you want to find out this value x1 comma z2, it is nothing but the first row and second column. So maximum of inside 0.6 into 0.3 comma 0.5 into 0.1. So what will you get? 3.5 into 0.1, it is 0.18. When you multiply this, you are getting 0.18. When you multiply this, you are getting 0.045. So when you take a maximum, you are getting this. Next, coming to the third value, x1 comma z3, it is this value and third column. So 0.6 into 0.4 comma 0.5 into 0.6. Okay, take the maximum, you will get answer as 0.3. Next, coming to this fourth value, x2 comma z1, it is nothing but this second row and first column. It is 0.1 dot 0.7, 1 dot 0.9. Okay, so you are getting 0.9 here. When you want to find out x2 comma z2, it is nothing but second row and second column, 0.1 into 0.3, 1 into 0.1. Okay, so you are getting 0.1. Next is x2 comma z3, it is nothing but this second row and third column, 0.1 into 0.4, 1 into 0.6. Okay, so it is x2 comma z3. Next is x3 comma z1, it is third row and first column, 0 into 0.7, 0.7 into 0.9. And for the next value, it is third row and second column, third row and third column. So when you find out all these things, you will get your answer like this. So this is your resultant matrix. Okay, so you can see this. This is dot product I have taken. So I am getting here. When you take a dot product, I am getting here, and last is I am getting this 0.43. So I'll substitute all the values here. I'm getting the answer to be, this is the max product. So when they are asking you, when they are giving you two compositions, they are asking you to find out max min composition and max product is very similar only. So just you have to put maximum outside, and for max min you have to take minimum composition, and when you are going for product you have to use product. Okay, that's all. That's the difference, and it is similar to a multiplication of two matrix. Okay. Next problem is, consider they have given you a fuzzy relation. They are giving in a matrix format. So the relation contains x1, x2, x3, x4, x5 rows, and we will name it like this: y1, y2, y3, y4, y5. And they have given all the membership values. They are asking you to find out whether this relation is a tolerance relation or not. So we all know that a solution is said to be, a relation is said to be a tolerance relation if this particular relation satisfies both the reflexive and symmetric property. Reflexive and symmetric property. First we will check whether this relation satisfies reflexive property. What is reflexive property? You need to find out whether the xi comma xi should be equal to 1. So when you check this, so xi comma y1, this one, and x2 comma y2, this value, and x3 comma y3, this is 1, x4 comma y4 is 1, and x5 comma y5 is 1. So all this value, when both the row value and column value are the same, then you need to find out the membership value. In all these membership value, the values are 1. Then it says that this relation is a reflexive property. So it satisfies reflexive property. So x1 comma y1, x2 comma y2, x3 comma y3, x4 comma y4, and x5 y5. Everything, all the values are 1. So it satisfies reflexive. And what is symmetric property? Symmetric property is the membership function of xi comma xj will be equal to membership value of xj comma xi. What do you mean by this? This is nothing but when you take this membership value, it is x2 comma y1. So when you take the reverse, it is nothing but membership value of y2 comma x1. What is this value? This is 0.8 and this is 0.8. So they are same. They are reflexive. Again, you need to check this and this are same. 0.4 and 0.4 are same. Here 0.1 and 0.1 are same. 0.2 is same. Here 0.9, then 0, 0. 0.5. So when you take a diagonal, so all the values in the left hand side, upper half and left hand side, it should be same. So when they are same, then you can say that relation is symmetric property. So what I have written is, so it is nothing but membership value of x2 comma y1 will be membership value of x1 comma y2. You are getting 0.8. x3 comma y1 is x1 comma, you need to interchange the values, row and column values. So x1 comma y3 both are same. Likewise, you need to check for all the values. When you check if you are getting the same value on both the sides, then you can say that relation is symmetric. So if a relation satisfies both reflexive and symmetric, then we can say it is tolerance relation. Okay, this is what they'll be asking you in fuzzy relations. You should know what is if any that is like if any two fuzzy set is given, you need to know how to do a Cartesian product. In Cartesian product, just you will be finding out the minimum of two membership values, and you will be finding out the matrix like this. And if they are asking you to find out the composition between the two relation, you need to use a composition like similar to a multiplication, and maximum outside and inner side you need to find out minimum. Okay, and when you are asking for max product, is nothing but max of the product of two membership values. And the next one is, if they are asking you to if they have given any relation and they are asking you to check whether it is tolerance relation or not, for that you have to check whether it is reflexive and symmetric. If it reflexive means all the diagonal values will be 1, and symmetric means all the values both in the upper half and left half of the diagonal value, it will be the same. So then you can say that relation is symmetric property. Okay, thank you all for watching.